Indeed, welcome to the show.
Indeed.
Hey, James. Hey, Fiona. Yeah, glad to be here.
Yeah, why don't you take a few minutes and let our viewers know who you are, what you do, and what we're going to be talking about today.
Yeah, so I'm Sandeep Advankar. I'm a senior product manager for AWS, particularly their services. We're going to talk about AWS Glue Catalog. Also, we have permissions layer, which is called link permission. I'm based in the Palo Alto area, Bay Area. It's great that we're talking about Oktoberfest and the fall is coming this weekend, and the baseball season is also in the full swing to play out. Yeah, excited about all that.
Okay, so let's build this up. Let's start. Can you give us a really quick overview of what Glue is? We'll start there first. Doesn't have to be deep, but let's just start. What are people using Glue for?
Yeah, Glue is one of the key service in AWS, which allows you to kind of take the data wherever it is, bring it, transform it, catalog it, provide the permissions on it. And it's used in every day, right? Like we have a large number of customers under different verticals. Like, for example, we talk about this baseball playoffs, right? I went to San Francisco Giants game. I took a driverless taxi there. It was amazing to kind of have this driverless taxi and still feel very safe. I feel like, okay, I don't need to worry about anymore who's driving and how much experience they have. Because the autonomous vehicle, they have millions of miles of data which have them trained for driving, right? So they know like all the context and all that. So that's one example in which the systems get this huge data sets, they get trained on it, and now they are ready to have put it in the real life practice, right? Driving on the actual road. So Glue helps in many of those cases. You have this, you can build this what you call data lakes, which is any data that you have, you go and put it there. For example, going back to the driverless car, right? They have like 10 or 12 cameras, each capturing megabytes per second information. They capture like terabytes of data, and you want to kind of store it somewhere, and then you want to analyze it. You want to use it for training your model. You want your driverless system to be perfect. So Glue helps in kind of bringing that data in a data lake, cataloging those, for having permissions on those, and then really making it available for the AI ML models to start using those.
Yeah, so I always mention that, like, say if you're getting data from different areas and maybe a different like manufacturer piece of equipment, and I always say like world coordinates or something, and maybe this device has the coordinates separated by a comma, but this one has them separated by a dash, and you need to transform that data because you want it all looking the same as it goes through into your data lake. We're talking ETL type of things here. Glue is going to help with that too, kind of bring it all together to where you want to use that data.
Yeah, absolutely. So and the models are changing, right? So earlier we had this model about a data lake, which are primarily any data you get, you store those and you go and query those. Now we are coming to a kind of new world where we have high streaming data, which is coming at, as you can see, one vehicle producing terabytes of data. You have hundreds of thousands of these vehicles and maybe in the millions in the future, which is going to produce this data, which is really valuable. And the paradigm that is emerging, we call it transactional data lakes, right? That's where the Apache Iceberg comes into picture. So you have this data, which is not only you can take it and store it and use it for analysis, but you can actually keep on updating it. So transactional systems are very common in terms of like databases, data warehouse, but they were not so common when it comes to like petabytes or exabyte scale data. And now you have these new standards, and one which we'll talk today, which is Apache Iceberg. Right? So Apache Iceberg is that open source standard which enables customers to have the transactional data lakes.
Okay, so we're talking massive amounts of data here. I mean, if I'm gonna get in an automated car, I want it to have those millions of miles of experience, and for it to have those millions of miles of experience, I need a data store that can hold lots and lots of data. And so you're saying Iceberg, this is a good fit for use cases where it's massive amounts of data?
Yeah, absolutely. I mean, this transaction data lake formats is a big thing, right? Iceberg is, of course, one of the open source which is there in AWS. We of course support all. There are others like Cody and Delta, we support that as well. In this particular context, we're going to talk about Iceberg because we made some specific improvements on Iceberg is standard, but you still need a ways to manage those tables, to make those optimized so that the queries and AI/ML work fast and reliable. And customers can do it, but then they have to kind of build their own infrastructure and they understand the changes in the data, which is very rapid. And based on that, apply optimization. We make it easy pattern, right? You go, you enable the optimization, and under the hood, we'll manage all the optimization of the data lakes.
Okay. And so it might need optimization because you're saying there's so much data, it's coming from so many different places, it might become complicated. Like they have different data types. You said it's transactional data, so it's gathering point in time. Am I right with that portion of it?
Yeah, exactly. Right. So this transaction, to give an example, right? We have customers who have like a social networking, and they have these feeds coming in from social networks every 10 seconds, every 30 seconds. And these are like small, maybe that's a small file, like 10 KB files. But you gather that, and suddenly you have like 50,000 10 KB files. And if you start querying it, even just reading those 50,000 files takes a long time, right? So,
yeah.
So one of the easy optimization techniques we launch is called compaction. So these are like, you consider like we have like bin packs, and you let's say you have 10 bins, and you pack all these 10,000 files of the 10 KB in those packs, and you construct like one or few of these compacted files, and these becomes very performant. The query engines need to only read the file once, and then they can act on it, and that all happens in the background, right? The customers don't have to worry about it. The data lake keep on streaming the data, we will compact it. And the other two optimization technique we just introduced last week, happy to talk about it more. Yeah, and so just the other two techniques we introduced is one is called the snapshot retention, right? So the way of transactional system is every time the change happens, they create snapshot. And each of these snapshots are great in terms of what we call time travel. So I want to know what happened maybe yesterday, and I can time travel, and my queries and others works as it is. I just need to give a time. But many times, since the data is coming so fast, I don't need to keep it what happened like 10 seconds before or a minute back, right? I may want to just keep only certain snapshots, and I could provide a policy for it. And then I want to get the system to be clean. Otherwise, the query performance again drops. And if I keep all these snapshots around, it's going to increase my storage cost. Right? So we introduce a optimizer for enabling snapshot retention capability where customer can provide that, and we will manage the kind of retention and the cleanup of it. The second optimizer we introduce is something we call it orphan file deletion. Sometimes what happens, these are dynamic systems. Sometimes things fail. There are certain files that make it created. We call it orphan, means these are like unreferenced files. And these keep on accumulating, right? And so we want to run this optimization where we identify unreferenced files and kind of clean it up. And so those are the couple of new optimizers we just launched, and we have a blog post as well out. Yeah.
Very cool. All right, pop quiz, Jeff. Can you quickly describe those three optimizations that Sandeep just told us about?
Yeah, so I guess I'll summarize just to make sure I'm thinking the right vein here. So we have Glue, which is bringing in data from everywhere, different sources. And then we have Glue Data Catalog. And part of Glue Data Catalog is we have an option of how to store that incoming data. And a good open source option is Apache Iceberg tables. Now, based on the amount of data, and especially since you said streaming data, that means there's going to be a lot of little files. So I know one of them is combining a bunch of little files into larger files to make things easier.
Yep.
And one of them is going back in time, so that's going to be with the snapshots. And Fiona, what's the third one? I can't think of it right now.
The last one was unreferenceable files. Is that right, Sandeep? So there's some files that can't quite make it in, and we want to get rid of them.
That's right. Yeah, it's an unreferenced file. We call it orphan files, or they are basically Iceberg doesn't know about these files exist, and we want to make sure we have the clean system for the high performance.
Okay. Did we pass the pop quiz, Sandeep?
Yeah, absolutely. Yeah,
So,
perfect.
Sandeep, what's interesting, I heard you say that there's a way for customers to kind of do this optimization themselves, but you're here to talk about the new feature that allows those three optimizations to be done automatically. Um,
Exactly. Yeah.
can you give us can you show us how that works?
Yeah,
Give us a little demo.
absolutely. Yeah. Let's go there. All right. Okay, perfect. So we have this blog that just out, and whatever I'm going to demo it, you can just go and click on this button here, which is launch stack, and you will have the entire system up there, right? So when you click on it, you will come to this cloud formation
So,
page,
so
and
this cloud formation stack is sort of like an environment for you to play around with these new optimizations, correct?
well, yeah, exactly. And
Perfect.
what this stack will create is what's shown in this diagram, which is we have this trigger which triggers every 10 minutes certain set of data, like 10,000s or thousands of these rows gets added to this data lake. In this case, is Amazon S3. The merge of the data happening, deletes is happening, and then you have this Apache Iceberg, which has a specific distinct way in which how the data is managed. There are multiple layers of how the data is and how the metadata is gets handled and manifest and all that. And we make that very easy, right? So when you go and when you create it, you will see that it show up in the Glue catalog. So in the Glue catalog, you'll see that, okay, I have this table that's get created, which is the Apache Iceberg table. This is particular the database. And then right now I need to enable these three optimizers, which are compaction, snapshot, and orphan file. This is where the actual data is. So you can go and actually look at the data. And the data, as you know, in Amazon S3, you have a bunch of these files you'll see, which is JSON, Avro. These are how the internals of Apache Iceberg is. And many of the times, these are the structures you want to kind of understand it, but you don't. But these are the standards, right? These are the for data engineers to look at. And what I'm going to do is there's an option here where optimization enable, right? It's as simple as making it enable. You can use the default setting and you can enable it. So there are, as we talked about, compaction, snapshot retention, orphan file deletions. These are the ones. In this case, I'm going to customize so that I can show you the different options. So you provide the role. For example, I have a role created here. And then I can specify how long I want to keep it. Either I can use the default configuration, or in this case, let's say I want to just use it for 1 day, and then how many snapshot I want to retain, right? And I can just use
So we're
one.
saying that the default retention period is here for 5 days. So a snapshot older than 5 days old, if you do the default,
Yeah.
it'll delete those for you. Okay.
Exactly. Yep. And then I have aggressive policies of deleting the unreferenced file, and I acknowledge and I enable the optimization, right? So that's the thing that the customer have to do is just go and enable it on a table, and then they will have the compaction status enabled and auto file deletions enabled, and they can see the optimization configuration right here, what I have specified, which is the compaction and snapshot. In this case, I'm using the same IAM role for each, and this is my policy or the configuration I want to be applied on the table. I've done that before, and I've seen that I can see the history of this. So I've been using this table for a while, and I can see that, okay, right now I have not, for example, in this case, but today it found that there are certain manifest files that are eligible for expiration. So it go ahead and deleted it. If I go and look at kind of in general how it happened before, previously I had large amount of data that I was streaming in, for example, here, and it found that based on my configuration policies, certain things are eligible for expiration. In this case, sort of manifest file data files, and it went ahead and removed those things. And similarly, I can see the compaction history history as well. So the way, yeah, go ahead.
No, sorry, I was just saying, well, I mean, this seems really cool. Have you talked to customers who've been managing this themselves previously? And if they told you, how much time they've been spending on this, how much time this might save them?
Yeah, absolutely. So one of the biggest thing is what's happening under the hood, right? So when the customer have to do something of this while their jobs are running, for example, I have these jobs running, right, which is continuously adding data. What they have to do is like understand the changes in the data, and then decide, okay, when should I trigger the any of these optimization actions, right? And so that's all is something handled under the hood. So what we do is, as the streaming data comes in, we have this concept called, we call it entropy, which basically means simply a counter of the data changes per bucket or per folder basis. We call that partition. And we say, okay, new files added, we increment the count. If the files deleted, we decrement the count. When the count reaches certain threshold, we call it breaching the entropy. We start the compaction, right? So there is a quite a bit of engineering that happens under the hood to make sure we have the optimized way when to start the compaction and then when to run it. Kind of making sure that you have the optimal experience at the lowest cost possible, right?
Yeah, and I can imagine customers coming to you and the service team saying, "Can you help us write automation scripts to do this thing?" And so that when that happens, then everyone does it slightly different, and you kind of it takes a while to get perfect. Here, it's right in the console. You're seeing a history, and it's the same for all customers. And I can see how that's a benefit for everyone to make everyone's life a little bit easier with all these optimizations.
Yeah, absolutely. And then the good thing is they can see that the benefits right here, right? So it's integrated with the cloud vault. So if I go in the metrics, in this case, I was streaming the data, right? So I was continuously adding the objects. So it went from for fewer to thousands of these objects, and then I turned it on, right? And then you see the effect. Even though I kept on streaming the data, it is able to find which data is which are the files which are based on my policy are ready to be expired, and it's able to kind of reduce the files and in terms of storage cost, right? So earlier my storage was like 400. It started with less than 400, and then as I added the data files, it kept on increasing. I want to retain the data which is important and which is needed, and corresponding snapshot, but I don't want it to go to like huge, right? It can go to, like, in this case, it went to like 22 gig. And so this snapshot and auto file deletions are able to kind of remove the files which are unneeded and bring the cost down and increase the query performance.
Gotcha. So are you thinking like options of if there is a file coming in every 5 seconds, let's after so many days we save one every minute or we delete the other ones, or is that kind of what you're talking about to reduce those file size?
Yeah, so the files, the current snapshot always has all the data, right? So that you want to maintain, and that's definitely. Now you're talking about snapshot which had happened previously, and as the new file comes in, it creates a new snapshot. It's similar to a version, and the way the standards work is by default it keeps everything, right? So it keeps all the versions, keeps all the snapshot, it keeps on accumulating, right? So data keeps on accumulating. So there are certain regulatory reasons as well, right? Like they may say, okay, I do not want to keep this data. I want to remove the data which is maybe 1 month old or 5 days old. I want to definitely keep the current data. And so there are aspects of GDPR and other part, but along with that, the query performance and storage costs also matter to customers.
Gotcha. Well, I can imagine where those settings, like I said before, writing those scripts and everything, that's probably involves a software team, some DevOps, and now we've offered that as a serverless feature that it's just a click of the button in the management console that's synced with everyone. I can see how this can make a lot of customers' lives easier.
Yeah, and we had this early adopters of Apache Iceberg, right? Who actually went and wrote this multiple Spark jobs and wrote this eventing pipelines to understand the changes. But they do have to hire like army of data engineers to build those, right? And here we are kind of providing this all with the single click of enable, disable, providing it all under the hood.
Totally. There's one step, one thing to do. You just have to enable it, and then you're set. You're good to go. Just like if you're at Oktoberfest, just got to put on your lederhosen. You're having a good time. One thing to do.
Strap up, and get going.
Exactly.
So it sounds like if you're working with Iceberg tables and you're streaming data, and you're dealing with having a ton of files and data retention, and you're looking for a way to optimize, utilizing Glue Data Catalog has some automations in there for you, and that's what you're here to announce today. So where would people go, Sandeep? It looks like you pointed us to a blog post. What you just showed us, it seems like anyone can go to this blog and deploy this CloudFormation template and play with it themselves.
You give us instructions on there?
Yes, we have all the instructions. Whatever I walked through is you just click on this launch tag. It will set everything up, and you have the easy ways how to enable the snapshot retention, how you enable all the optimizations, configurations. And if you want to do it through APIs, we have ways to do that as well. And and you validate solution yourself, right? Like you look at your state of data and see how the optimizers will help you in that. And so it's right there for you. Try it out. Looking forward to your feedback.
Great. Yeah. And I know we've put in our producers have put in the chat comments the link to that blog post. But Sandeep, thank you very much for joining us and sharing these new features of Glue Data Catalog. We appreciate your time, and this was really exciting.
Thanks so much.
Absolutely. Great to be here. Thank you.